Hello everyone. Welcome back to Academy-Toán. So let's see what we do today. Last time we learned how to do word problem by using linear equation, right? So today, according to our syllabus, I think we're going to jump to another concept called linear inequality. If you guys remember, first time I introduced to you guys the linear equation, and I said that I brought down two algebraic expressions, one on the left hand side, the other one on the right hand side, and then between them, I put the equal sign. Okay, if so, I put the equal sign, I just create an equation. You see the term equation, it comes from the word equal. All right, so we have two algebraic expressions equal to each other, which give you equation. Now, what if it's not equal to each other? What if one side is greater than the other or less than the other side? And if it's greater than the other or less than the other side, we call that inequality. Okay? Inequality. It's the opposite of equality. So we call it inequality. Right? So today, we can learn what inequality is about, how to express inequality, and how to solve inequality. So let's get started. Should be the section that 6. Inequality. And for the equation, we have an equal sign. For inequality, we use a different symbol. We have greater than, less than, or greater than equal or less than equal. All right. So first, intro. So we have 4 different symbol for inequality. One is greater than. So this is mean greater than. Less than. So if you have the arrow pointed to the left, you have less than. So you have greater than, and you put the bar like this. So we have greater than equal, or equal. And this is less than or equal. If you see algebraic expression containing one of these symbols, then that is inequality. It's not equation anymore. It is inequality. Okay. And I can give you an example really quick what it looks like. What if I have something like this? I have x greater than 2. This is inequality. It's very basic inequality. It means that all the value that greater than 2, or I can have x less than equal to -3. This is inequality. It includes all the value that less than or equal -3. Okay, so you can create any inequality you want, or you can just take an equation and you throw away the equal sign and you put an inequality sign over there, one of these inequality sign, then it gives you inequality. Okay, and there are 3 different ways, actually 4 different ways But for this course, I just show you 3 different ways to express inequality. The example I'm giving you here actually is one of the way already. We call that algebraic expression. Okay, we're gonna go through each way of expressing inequality, and I will give you an example for each method. All right. So second Roman, inequality expressing. The first one we call algebraic expression. One of the way to express inequality is called algebraic expression, and the one I already give you is algebraic expression. I can write like this: x greater than equal to -5. Okay, or I can write x less than 10. These are algebraic expression of inequality. Okay. Number 2, we call that set builder notation. Set builder notation is actually using the algebraic expression there, but you put the whole algebraic expression into the pair of curve bracket, something like this. So I'm gonna use the first one over here. Okay, I'm gonna put into the curve bracket like this, and I always write x and a vertical small bar like that, and x greater than or equal to 5. Okay. So that is set builder notation. Okay. Or I can write x and x less than 10. Okay, so this set builder notation. Just so you can express any inequality, I'm talking about the solution, the x, in terms of the x inequality in the set builder notation. Okay. Actually, you can write 2x less than 10 or so. It depends. But one of the way is using the curve bracket method. It's called set builder notation. Okay. And the third way we call graphing expression. Okay. Again, for example, if you have x greater than or equal to -5, and I want to express on the number line, I mean graphing, you're gonna write a number line. Okay. Okay. And over here 0, right? And -5 on the left hand side of 0, so -5 right here. Okay. And the equal mean over here, it means included -5. So when you included -5, you draw a circle, a dot. Okay. And the arrow, it points toward the right, right? So you're going to set everything to the right. Okay. Right. So be careful with the dot and the circle. If it is not included, for example, in the second case, so 0 here, 10 here. Okay, I'll just say it's positive, negative. It's not included 10 because you see, you don't see the equal sign. If it's not included, you're gonna draw the open circle, and you see the arrow is pointing to the left, right? So you set everything to the left. Okay, so that is a graphical expression of inequality. All right. But when you read inequality, you must understand it. For example, over here, when they say x greater than or equal to -5, You see that it means that it includes a bunch of numbers. So many numbers. As long as it's greater than or equal to -5, that is satisfied that, right? That satisfies the inequality x greater than or equal to -5. And x less than 10, it means that include all the number less than 10. For example, 9.8. For example, 9.99999. It's still less than 10. So, and because it's less than 10, that always satisfies this inequality. But so 9.9999 is satisfy that inequality. -5 is also satisfy inequality. Negative 100 or even negative a billion is also satisfy this inequality because it's less than 10. Okay. Okay. So you see that the solution of inequality contain many values. So the difference between inequality, we already see that for inequality, the solution has only probably 1 or 2. Okay, for equation. Okay, but for inequality, the solution contain many infinite many values. Okay, but how we're gonna solve inequality? Before we can solve inequality, I want you to know these two important property that you have to use a lot during the process of solving inequality. Okay, so the first one, the third one, so solving inequality. Okay, and the property I want you to know is called addition property of inequality. The second one we call modification property of inequality. But let's jump to the addition property first. The property state that if I have a greater than b, if I have a greater than b, greater than, okay, simple. And if I add both sides, okay, if I add both sides of the inequality a greater than b to a number c, okay, to a number c. See, I add a to c, I add b to c. Then the inequality sign does not change. So it's still greater than. Okay, this is mean imply. So if a less than b, then if I add both sides to the inequality on a number c, then again the inequality sign does not change. The direction is still less than. It's the same as the original. All right. The second property we call it modification property of inequality. I just want to make sure that I'm recording it. Hold on, let me see. Okay. And the modification property state that if I have a greater than b, okay, and if I multiply both sides by a number c, and that number c is positive, okay, and C is positive. If I multiply both sides by number C, see that? Then the inequality sign does not change, so it's still greater. Okay, still greater. However, if you multiply both sides by a number C, but C is negative, see? And multiply by C, but C is negative. Then you have to switch the direction of the arrow. You see the difference between two cases? If C is positive, you does not change the sign. But if C is negative, you have to change the direction. Okay? And if apply for also division, if you divide both sides by a positive C, it does not change. But if you divide both sides by a negative C, then you have to change direction. Okay? All right. Now with these two properties here, I can solve inequality easily. Right? And the way to solve inequality is the same way as you solve equation. I mean, the general strategy. Every time you see parentheses, you distribute it. After you distribute it, you combine right term on the left, you combine right term on the right. Then you isolate all the x term. And finally, you solve for x. All right. Example. Something like this. What if I want to solve? Let's start with a very simple inequality. Okay, so the following inequality. Okay. What if I have something like that? I have 2x plus 4 greater than equal 6. Yeah, so you see over here, we have one term with x. Okay. But we have two constant terms. So our job is to isolate the term with x. Remember the strategy I put on the whiteboard when I show you how to solve the linear equation. So I need to get rid of -4. It means I subtract both sides by 4, which is give you 2. I subtract both sides by 4. 4 minus 4, 0. 6 minus 4, 2. Then in order to get x, we must get rid of number 2, right? Then how you get rid of number 2? This is multiplication. So in order to get rid of number 2, you divide both sides. So x greater than 2 divided by 2. Yeah. So you see that I divide both sides by 2. And 2 is positive. So I did not change the direction of inequality sign. It's still pointing to the right. It's still greater than equal. Okay, then my final answer is x greater than equal 1. And this is algebraic way, algebraic expression of inequality. What if they ask you to put it on the number line, graphic? All right, easy. So there's 0 here, 1 here, right? And because it's equal, so it's a dot. It means included. Okay. You see that it points toward the right, right? So you're going to set everything to the right. Okay. That is very basic inequality. Right? Now let's do another one. Let's do another one. How about this? How about this? So negative 5x plus 7 less than 2x minus 2. So every time you see parentheses, you distribute it. So I keep this, distribute it, I forward it to x minus 6. Right? And remember, all the x term must be isolated to one side. So I always isolate it to the left. So it means I need to get rid of 2x. I subtract both sides by 2x. Give you negative 7x. Right. Then I get rid of number 7 right here. Remember the strategy is what? The strategy is all the x term must be on one side. All the constant term must be on the other side. So we're not allowed to have this constant term on the left. So I subtract both sides by negative 7, which is negative 13 on the right hand side. Now what? In order to get the x, you need dividing both sides by negative 7. And according to multiplication property, we say what? If you divide by negative number, you have to change direction. So instead of less than, it's greater than negative 13 over negative 7. Right? And negative 13 over negative 7 give you 13 over 7. Okay. And you can express it on the number line easily. So 0 here, 13 over 7 here. And it's not included because it's no equal here. So that's why you have to use the open circle. And the arrow is pointing toward the right. So you're going to set everything together. Right? So I mean, the strategy is kind of the same. Oh, and you can put it. You can put the final answer in set builder notation also. You can write like this: x greater than 13 over 7. So you see, there are 3 ways to express the final answer: algebraic way, number line graphing way, and set builder notation way. All right. Let's do another one. Example 3. Let's do the one with fraction, okay? So I have 1 over 2 x minus 3 minus 5 over 3 x plus 1 greater than equal 3 x plus 2 plus 4. So this inequality is more complicated than the first example, right? First 2 example. But first one you have you have fractions. Secondly, you have 2 pair parentheses. Actually 3 pair parentheses. You have to distribute many times, 6 times. So let's distribute it first. Every time you see parentheses, you distribute it. So give you 1 over 2 times x is 1 over 2x. 1 over 2 times 3 is negative 3 over 2. Fraction multiplied by number. You set that number over 1 to multiply first. Okay. Negative 5 over 3x. Negative 5 over 3. Right. 4 greater than 3 times x. 3 times 2 6 plus 10. Plus 4. All right. Now we combine like term on the left. So negative 3 over 2 minus 5 over 3. You can do that on the side. Let's see. Let me get some scratch paper here. you don't want to do over here. Just use some scratch paper and work on the side. So you have negative 3 over 2 minus 5 over 3. LCD is 6, right? So LCD is 6. Some 3 here, some 3 here, some 2 here, some 2 here. So negative 9. So some 2 is 10. So negative 19 over 6. All right. All the variable term add them up. So 1 over 2x minus 5 over 3x. It means 1 over 2 minus 5 over 3. LCD 6. 10, right? Equal negative 7 over 6 x. All right. On the right hand side, it's very easy because you don't have to buy LCD whole number. So it's 3x plus 10. Okay. Now what I have, you see that I totally simplify a very complicated inequality to a simpler inequality. I have 2 variable term on each side. It means that I need to get rid of this. So I subtract both sides by 3x. So I have negative 7x minus 3x minus 19 over 6 greater than or equal to 10. Right. Then adding both sides by 19 over 6. Because all the constant term must be on the other side. All right. Now I can combine it because it's similar term. Have to find LCD. You know how to find LCD, so I mean I'm not gonna repeat it again. So LCD should be 6 multiplied by 6 over here, so 18. 18 6 negative 25. Nice. Real then. 10 plus 19 over 6. LCD again 6. Times 6 over here, 6 over here, 6 over here. 60 plus 19 is 79. Okay, 79 over 6. All right. Now, I want to get x. It means that I need to get rid of negative 25 over 6 first, right? But I don't think it's a good idea to get rid of the whole fraction at the same time, at one time, instead of just get rid of each number each time. Okay, so I'm gonna get rid of number 6 first. So I multiply both sides by 6. So you cross it. So you have negative 25x greater than 79 times 6. 5 47. Okay, right? Oh no, we already cancel out. Oh, I'm sorry. I already multiplied both sides by 6, so I already canceled, so 79. And now, and in order to get x, you need to get rid of negative 25. So in order to get rid of negative 25, you divide both sides by negative 25. And remember, when you divide by negative number, you have to flip the sign, the direction. So 7 over negative 25. So your final answer will be negative 79 over 25. All right. So so that is the way you solve inequality. It's not really that bad. The general strategy is the same as equation. It's just some step you have to apply multiplication property. Okay. All right. So that's all for the lecture today. If you have any question, please send me a message on Canvas. Again, you want to be good at anything, you have to keep practicing. The more you practice, the better you will become. All right. Then I'll be seeing you next time. Bye-bye.